Hi, this is Lloyd Alvarez, and welcome to my very first tutorial for aetoots.com. What I'm going to show you guys today is how I made this effect for the BDA and Promax Open a couple of years ago. So what we have here is a fun and different interpretation on the typical fireworks effect. What I did was use Trapcord Particular to create these fireworks that explode in the shape of flowers. This effect, of course, could be used to explode any image that you guys like. So let's dig right into it. Since this project was done for a client, I'm not going to use exactly those images, but we're going to rebuild it using some images I found on the internet. I found this photograph of a mountain with a mirrored lake, so we'll go ahead and not only show you how to do the fireworks with the flower explosions, but we'll also make it reflect in the lake, so it'll be a little bit of an added bonus. And then I also found this picture of a sunflower that we'll use as the image that gets exploded. So let's get right to it. We're going to create a new comp, and let's make it a square pixel just so everything is nice and even. And first thing we'll do is we will bring in these two mountain layers, and I'm going to parent them together so that I can scale down one of them. I'm going to hit S to reveal scale and scale that down so we have it nice in frame. Alright, so the first thing we're going to do is we're going to do the smoke trail. The effect consists of two particular layers. The first one is the one that does the smoke trail, and then the second particular layer is the flower explosion. So we'll go ahead and start with the smoke trail. To do that, we're going to select layer. Oops, we have to make sure we're in the comp. Layer, new, solid, or Apple Y or Control Y. We're going to call this particular smoke trail. Make it comp size, it doesn't matter what color it is, and then we'll go effect, Trapcode, particular. And then what we'll do is we'll go ahead and solo this particular layer so that we can see what's happening. So if we scrub forward in the timeline, we can see that in its default form, particular just emits particles in a uniform direction. So if we go ahead and go over to our particular settings and we twirl down emitter, you can see here that the direction, well, first it's a point emitter, which is all emitting from this point, and then the direction is this uniformly, like, all around. What we want to do is we want to actually use a directional, and you really can't tell at first because it actually puts it straight in Z space, so towards the camera. But if you rotate this in Y, by rotating here in Y, you can see now the little cone that it emits. So now you can see it's emitting in only one direction. You can also affect the cone angle by using the directional spread, which is this setting here, directional spread. But another way to achieve this effect is to use a light emitter. So what we're going to do is do that because it'll actually give us some other control that we're going to be looking for. So what we're going to do is go ahead and say layer, new, light, and make sure it's a spotlight and hit OK. Before, you actually have to name the light emitter. If you go into back to your particular layer and you go into options, here under the light emitters section is where you actually give the name of what you want the lights to be. So in this case, it defaults to emitter, but if you wanted to have several instances of particular in the same comp, all controlled by different lights, you could go ahead and change the prefix of the name so that you could have different lights controlling different instances of particular. But in this case, we're only going to have one, so it works fine. And once you do that, you need to switch the emitter type from point to light. So you can see that reset how this is happening, and if you see, again, it's pointing back. That's because now the light is controlling these rotations. So if we twirl down here and reveal the transform properties, X rotation is basically the same thing as we were doing before with the directional emitter. So we're going to go ahead and point that down. And then instead of directional spread, under light options, the cone angle is what controls the spread. But you can notice that when I close the spread all the way, the particles are still kind of spread around. That's because there is one control left in particular, which is the emitter size. It defaults to 50, but we're going to go ahead and set this to 1 so that we have a nice thin trail of particles. So if we preview this quickly, you can see that it's just a straight stream of particles straight down. Okay, so now let's go into the particle section. And the first thing we're going to do is make the particles a little bit smaller. They're set to 5, so if I scrub that, you can see now I have a nice thin trail. Let's go ahead and make this 3. It's a little bigger than we're going to use, but we're going to push it back towards the mountains so they'll get smaller as we push them back. And then the other thing we want to do is go under physics and start sort of messing with them a little bit after they're emitted. If you twirl down air, there's basically two things. There's the spin amplitude and then the turbulence field. The turbulence field essentially emits, creates this three-dimensional fractal field that the particles get pushed through. Let me quickly show you what I mean. I'm going to create a new solid, Apple Y, and I'm going to look for a filter called fractal noise. There it is, fractal noise. And basically this is what a fractal field looks like. If I increase the contrast, this might make a little bit more sense. Imagine if the particles are being pushed from the top coming down through an imaginary, well, it's not imaginary, but you can't see it, field that looks like this. And whenever it encounters the white areas, they get pushed away, and then the black areas don't push it away. So it kind of would snake its way through this, like kind of wiggle, sort of weird random pattern is how the particles will be affected when you put them through the turbulence field. So I hope that helps. I'm going to show you now. I'm going to go ahead and turn this off for a second so that you can see what happens if we go back to particular and we turn on effect position for the turbulence field. You can see how it's twisting it. What's cool about particular is it actually does it in 3 dimensions. So it actually is pushing it to the left, it's pushing it up, and it's also pushing it towards us and away from us, which is why it's kind of all cool and twisty like this. This is an extreme amount of twisting, as you can see, but I just wanted to illustrate what is actually happening. So if we look at this again, let's take a look at the fractal field. It's probably more, as you can see, it's actually smoother. It's probably more like a smooth, let's see, dynamic. See how it's more like, probably more like this is what it looks like, the fractal field, more of a puffy thing. Anyway, we don't need to use this. I just wanted to illustrate what's happening so that when you adjust your parameters, you can get an idea of what's actually happening to the particles. They're being pushed through that fractal field. All right, so we're going to go ahead and bring this way back down. Actually, and then if you see here scale, if I adjust the scale, it adjusts the scale of that fractal pattern. Here it's kind of chaotic, but if you imagine that whole fractal cloud field moving when we move it, we're going to move this, scale this up just a little bit so that we have nice random looking thing. Like I said, this is too much, but if we push this way back down, so just a little bit like this. And then also the size, you know, as they're being pushed through the same fractal field, doing the effect size affects how big or small the particles are. So again, if we do an extreme version, but we're just going to do a little bit like this. So if we preview this, you can see now that the particles are coming down in a more sort of random and organic fashion, which is what's going to help us with the illusion of the smoke trail. If we go back up here again now under particle, right now we're doing the particle type sphere. Particular, it's very good for doing fireworks and smokes and trails and stuff. As a matter of fact, there's quite a few presets for natural looking smoke trails and stuff. So they include a default particle type which is called cloudlet. There's 2 of them, smokelet and cloudlet, and they're essentially the same thing, except for the smokelet. The cloudlet looks like a little puffy cloud, and the smokelet is the same puffy cloud, but it's shaded, which helps it look more like smoke, and you can immediately see there that's starting to look like smoke. I think that's too big, so we're going to go ahead and bring the size down to 2. And that looks pretty nice. And if we preview that, you can already see. Now it might look a little weird up close like this, but when we push it back towards the mountain, it'll start looking more like what we want. And then finally, if we go ahead and animate the emitter light now, so whenever you move the emitter light, see it moves the whole trail with you. So if I go ahead and hit P to reveal position and set a keyframe, well, let's actually reveal the mountain as well. Let's go ahead and move this emitter back in space. So I'm actually moving it on its y-axis, but that's because I rotated it 90 degrees. But I'm actually moving it back in the comp's z-axis, and I'm moving it kind of back. And I'm going to move it up here towards the top of the mountain, because this is where I want it to start emitting. So I'm going to set a keyframe, and I'm going to push that keyframe back to 0, because that's where I want it to start. And then at about 1 second, I would say, roughly there, I'm going to move it up so that right to about the point where it would explode. If I hit A, which normally reveals the anchor point, for a light reveals the point of interest. As you can see, it actually created keyframes for both the position and point of interest. I'm going to turn off the point of interest keyframes, because I only want to actually keyframe the position. And if we zoom in here, we can actually see what's happening. So if we go back, you can see now that the particles are coming up. I'm going to do Apple Shift H to hide the boundarying box so we can actually see without the thing. So if I preview this, you can see now that it actually is shooting up. That looks about right. One more thing I'm going to do Apple Shift H again to reveal these back. If I hold down Option and Apple, or Control and Alt on PC, it turns my arrow tool into this pointer tool, corner tool, so I can actually pull out the Bezier handles here for the path, so it can actually have the path be sort of this rounded fashion, so it looks like a more natural. I can do it on the top here as well. There we go. So if we preview that, there we go. So now you can see it's kind of whipping around, which is looking more. This is one of the advantages of using the light emitter, that you can actually see and control the path in the comp window with Bezier handles and in 3D. If you just use the normal, if you go here and you use the normal controls, which are grayed out right now, the position X, Y, and Z, you'd have to control these Bezier curves in the layer window, which is not as neat or convenient. So, it's pretty good habit to work with light emitters. In particular, another benefit of working with light emitters is you can actually have several particle trails at once. So if I actually go ahead and duplicate this light, for example, Apple D, I'm going to delete the keyframes. Well, actually, don't need to. I'm just going to move this one over here. See, now you can see that I actually have 2 particle trails happening now. That's because each light is going to be, as long as the light starts with the word emitter, I'm going to preview that, see? So now I have 2 fireworks happening, and with one instance of the particular plugin. So it's kind of a neat, handy way of getting multiple emitters moving in different directions, but all behaving with the same settings in the one particular effect, which is pretty cool. So I'm going to delete the second light because we don't need that for now. Okay, so now once it reaches the top, I need it to actually stop emitting, because once it's there, I don't need to be emitting smoke anymore, because it's going to explode. So the way you normally do that is you go to your particular layer and you set a keyframe for the emitter particles per second, and then you go forward 1 keyframe, and then you set that value to 0. So if I hit U to reveal those properties and preview this, we can see now it hits the top and then it stops emitting. The reason those particles don't go away immediately is because if you go down here to the particle life section, every particle is alive or on screen essentially for 3 seconds from the time. So the last particles that are actually emitted here then are still alive for another 3 seconds before they go away. You can lower that value, of course, so let's go ahead and set that to 1 so that as soon as it hits the top, they disappear. Okay? So that looks pretty nice. And, the particles have inertia and momentum. That's why they're actually moving up along the way, which is kind of cool. All right, so here, let me show you guys a cool little expression trick for when you're working with particular. Um, if you've ever had to work a lot with particular, you find that you're always kind of modifying things, sliding things around. Let's say, for example, I wanted this particle trail to take a little longer, so I move this around. But then you also have to remember to move these two keyframes over here as well, and then make sure that they're lined up, and you have to zoom in. And then if you then have to change the value of particles, say I wanted to only do 50, you're like, oh wait, I forgot, and then this set another keyframe, so I'm going to have to delete that because you actually have to zoom in and make sure you're lined up on this keyframe to go ahead and change that to 50, which can be quite a drag, I think. So I'm going to show you guys a cool expression that avoids having to do all of that work. So I'm going to go ahead and make this a little bigger real quick. If you hold down the Option or Alt key and click on the stopwatch, it reveals the expression box. I'm going to go ahead and delete the default expression that it writes. So I'm going to widen this out here. Let's see. All right, let's go back in there. Okay. So essentially what I want to happen is I want the particles per second to stop emitting, essentially, to go from whatever value I was emitting to 0 as soon as it hits this second keyframe on this light emitter, right? So the first thing I'm going to do is refer to this position property on the emitter light. So I'm going to go ahead and say light position, and this is just a variable that I made up. I'm defining it, and I'm naming it light position so that it makes sense. And then I'm just going to say equals, and now I want to tell the expression what that variable is, and now I'm going to use the pick whip to call that position keyframe right here. And so it essentially then immediately just writes the code that's necessary to refer back to that position. All right. Now it's not referring to this keyframe, it's just referring to the entire channel. So now I'm going to make a new variable below it, and I'm going to call it last keyframe. All right. Again, I made up that word. It's just a variable I made up. And I'm going to say equal. So now that I've actually called this whole channel into a variable, I can use that variable, which is called light position. I'm going to copy and paste it here. And then if you do dot and then you do key, you can now, if you open parentheses, call these particular keys. So this would be key number 1 and this would be key number 2. I'm interested in key number 2, so I'm going to say key 2, close parentheses, and I'm interested in the time of that keyframe, not the value but the time, so I'm going to say time. All right, and then close that. So if I hit return now, because the variable always executes the last line of the code, it's actually telling me that the value is 2 because that's the time. It actually, because this doesn't actually show you decimals, it's actually showing me the main rounded value, which is 2. That's not what I want, but I just wanted you guys to follow along to see what's happening. What I want to do is I want to actually do a conditional that says when time, when the timeline time, the comp time, reaches the second keyframe, I want this property where we're writing the expression to go from whatever value you had for particles per second to go to 0. And the way you write that is you say if open parentheses time, which is the comp time, is greater than, and now we've already defined this time, which is last keyframe. So if time is greater than the last keyframe, and you just type last keyframe, then what do I want it to do? Well, I want it to give me the value of 0, so I just type 0. And then else, which is what you'd write to say what you want to happen if this condition is not being met. Well, then otherwise, if it's not after this, then it must be before, and before I want you to just give me whatever value I have typed in here. So you just write value, okay? And that's it. So now if you scrub along, you can see it goes from 100, and then as you cross the second keyframe, it goes to 0. And now if I move this around, no matter what these keyframes are, because this expression is overriding these keyframes, you can see now here it goes from 100 to 0. So I can actually delete these keyframes. I no longer need those keyframes because this expression is dynamically creating this value for me. Now, here's another more advanced tip. If you want to make this even more dynamic so that it works with no matter how many keyframes you have on the light emitter, instead of defining the second keyframe explicitly by putting the number 2, you can basically say there's a function that tells you how many keyframes are in a property group. So that's called num keys. So if I go and again I call back light position because that's what I want to know. I want to know how many keys are on light position because right there's 2, so therefore the number of keys is always going to give me the value of the last keyframe, because in this case there's 2 keyframes total, so keyframe number 2 is the last one. If there was 3 keyframes, then it would give me the value of 3 and so on. So inside of the parentheses where I used to have 2, I now say light position and then dot num and then capitalized keys like so. And then that now if I have another position keyframe here in the middle, it's smart now to not go to 0 until after it reaches the last keyframe, in this case keyframe number 3. Alright, so that little bit more of advanced dynamic things. And what's really great about writing expressions like this is once you write them, you can just close them and forget about them, and then no matter what you do, your little particular thing is going to be doing what you want, which is fantastic. So I'm going to go ahead and delete this keyframe because we don't need it. And I'm also going to change this value from 100 to 50. So now as you can see, it goes from 50 to 0. Great. All right. So that now concludes the first part, which is creating the smoke trail. And now we're going to create the flower explosion. For that, we're going to create another solid. And we're going to call this particular flower. All right, same comp size. Hit OK. And we're going to add the sunflower. Okay. Now the way that we're going to use what's called the layer emitter. The way this works is it actually emits the particles from wherever this layer is positioned. So if I turn off particular for a second, I can then position this flower at the top where I want them to be emitted. Now I'm actually going to do a little cheating trick, and I'm actually going to put it almost to the top of the comp. Well, even though that happens to be where it coincides with where I want it to explode, I'm going to show you why I actually want it towards the top here. Alright, once I have it there, I can actually turn off the sunflower layer, turn back on the particular flower layer, and solo this one as well. And to this I'm also going to apply trapcode particular. And again, we're stuck with the default emitter. So the first thing we're going to do is change the emitter from point to layer. And once I do that, I need to define which layer I want that to emit from. So I'm going to select the sunflower. And it immediately tells me that layer emitters must work with a 3D layer. So if you follow the directions, which essentially tell you to deselect it, turn the layer, oops, not the particular layer, but the actual sunflower is the one you want to make 3D. Then we can go ahead and select it again. And so now you can see it already gave me some particles. It's quite sparse, so if you actually turn up the particles per second, you can see now that it actually starts filling in what's starting to look like the sunflower, which is kind of cool. All right. And what we're going to do is we're going to actually go back to 0 and preview it really quickly. So you can see there that what happens is the particles kind of pop up kind of from all over and then start spreading out, right? So I'm actually going to make, I'm going to make these, I'm going to make the sunflower layer slightly bigger. So I'm going to turn it back on, a little bit bigger. It's being covered by the particular layer, so I'm going to turn it off again. And I'm going to make the particles a little bit smaller. So under particle size, I can make the size smaller. Let's make that 3. And bring up the values again. Particular is great. You can actually have tons of particles. Here we have almost almost 40,000 particles, and look at how quickly that previews. It's fantastic. And what's cool now is it's starting to look kind of more like our sunflower. So what I want to do is I want to scrub in the timeline and find the exact point where It looks like the sunflower, but before it starts dispersing. So I think that point is right about there. So now we have this kind of cool sort of, particle-like rendition of our sunflower, and that's where I'm going to actually stop emitting the particles. So I'm going to do the same thing again. I'm going to set a keyframe for the particles. I'm going to go forward 1 frame, and I'm going to go ahead and set this to 0. Now, unfortunately, this is not following the same light emitter, so I'm not going to be able to do the same expression trick. But I wanted to show you that anyway because it's very handy. Because I'm not using a light emitter on this one, I'm not going to use that. But now once I have this here, I want to actually make sure that, see, now the particles are kind of getting cut off towards the top. I'm going to go ahead and move. So if I reveal P for position, I can actually move it down. And it's not going to actually update until you kind of reset it. So let's actually turn this off, turn this on, and move it down. We want it there. Okay. And turn this back on and solo this. So now the particles are not being cut off, which is great. And what happens is right now they're emitting kind of in like 0 gravity. In reality, they would actually start falling. So what we want to do is turn on gravity. So if I go for the particular flower, under physics, I'm going to see gravity, and I'm going to just turn the gravity up. Ooh, that's too much. Let's just do like 10 and see how that looks. Preview that. So you can see there the particles start falling down, which is kind of cool. And as well, we're going to add a little bit of that turbulent field. For this one, we'll just do a little bit position, just like 10 as well. And then another thing that you can do under air physics is you can actually turn on spin amplitude, which is essentially this makes the particles spin around themselves after a defined time. So here it says time before spin is 1 second. So I'm going to turn this up to like 10 as well. So after like 1 second, I mean, it's going to start spinning with an amplitude of 10 around itself. So they're going to start kind of like wiggling, which is going to be a subtle effect once the flower's kind of pushed off into the up back, but that's pretty cool. And I think they can actually fall just a little bit longer. So let's increase the lifetime for these particles. Oh, look, they're actually kind of long. Let's actually reduce the particle life. Let's go to 2 seconds. Which I think is going to affect slightly the point where we chose. So if we go again and zoom in and pick the exact point where it actually forms, which I think is right there, and reveal the keyframes, you can see that it's still in the same place. Excellent. So what we're going to do is we're going to make, this is where the little trick comes in. In order for it to actually feel an explosion, like an explosion, I'm going to actually scale it from the center. But at the moment, if I scale my particular layer, well, it actually is working. Look at that. I'm actually going to push the anchor point by using the pan behind tool here. I'm going to put that right in the center. And if I turn off the solo, I can now position this. If I go here to the emitter and I go to the point where it reaches the top, I'm going to now grab both. Now this is what's tricky. You got to actually move all these elements together. So I'm going to move both the sunflower in the particular layer, and I'm going to slide these over so that it actually is at the exact moment, and I'm going to preview that there. Okay, and then I'm going to move to where it exploded, and I'm going to scale it down to the size I want it to be once it's exploded, which is roughly there, and then I'm going to move it so it matches the same position. And now I'm going to set, for the particular layer, I'm going to set a scale keyframe, scale, and then I'm going to go back to 0, or back to the beginning of that layer, and I'm going to set the scale to 0. And now I'm going to preview that. So now you can see that it scales up as soon as it hits. So as soon as the particle reaches the top, it scales up and then it starts dispersing, which is kind of cool. I think it's a little bit too big, so I'm going to scale that down a little bit. And let's actually move it up just a hair. Just cheat it a little bit. So as you can see now, it's starting to look like our final effect. Excellent. So now what we just need to do is move, well, actually two things. We need to move the smoke behind the mountain, which we can do easily because I previously cut out the sky from the mountain. So if you see here, I actually have it as two separate layers. So I could just, first of all, I could easily just move the mountain above, but to do the to do the reflection, I'm going to pre-compose all my particular layers, and to do that, this is automatically created layer emitter light when I created the layer emitter for the sunflower. That's automatically locked. So I need to unlock that, select all of those, essentially select all my layers except for the mountain in the sky, and I'm going to pre-compose that by doing Apple Shift C or Control Shift C, and I'm going to call this particular firework with trail. As you can see, I like to be very explicit in my naming, because once you start having complicated comps, it's very easy to lose track of things. So if you have good naming techniques, you will thank yourself later. So hit OK, and so now I have it all as one comp. I can now simply duplicate this, move the mountain in between these two, and then take the top one, hit S for scale, and then in the Y property, do a negative value, which will invert it. Let's move forward so we can see it. And you can immediately see that we have our perfect reflection. All we have to do is fade it now. And I'm going to do that by creating a new solid. Comp size. I'm going to now put a ramp, so I search for ramp. And if I toggle the switch here, if I do a Luma matte, I'm going to use that ramp as a Luma matte for the reflection. So right now it's inverted. If I undo really quickly, so wherever it's black it's going to be transparent, and wherever it's white it's not. So what I really want to do is invert these. So I'm going to do this so you can see what I'm doing. So I've inverted the ramp. I'm going to set this back to Luma matte again, and so now you can see that as I move this around, and that's what's cool about doing this, is that you can interactively set this so you can see what's happening. So I can see a nice gradated reflection. Alright, so there you go. So let's go ahead and preview that. Very nice. So that's it. I hope you guys enjoyed this tutorial, and I hope you learned a few tricks, and if you have any comments, please feel free to let me know. Thanks a lot.